Welcome back to the perfect squares calculus conundrums about the derivative of a function. So in this video we're going to talk about the chain rule, but mostly we'll focus on the general power rule. Basically what the chain rule says is that if you have a function that's a composite of two functions, like if you have a function here y that is composed of function f evaluated at g of x, then the derivative of the y function would be the derivative of y with respect to u. We're letting u be this g of x. So we're saying u is this g of x. So we would say the derivative of y with respect to u, and then times the derivative of that g of x with respect to x. So that's a little complicated, so let me give it to you another way. If you have the derivative of f of g of x, if you want to find the derivative of f of g of x, then it would be the derivative of f with respect to g of x, and then times the derivative of g of x. Now I like this one, where you let u equal the g of x. So here we say if you take the derivative of f of u, where u is the g of x, then that's simply equal to f prime of u times u prime. So that would mean f, the derivative of f at g of x, times the derivative of g of x. So it's the same thing. Now, what's interesting is this rule can be applied to a number of functions, but at this point, the only rule that we have that we can apply it to is the power rule. So when this chain rule is applied to the power rule, then the power rule looks like this. Remember earlier I gave you the simple power rule, where if you had x to the n, the derivative would be n times x to the n minus 1. But if the function that's raised to a power, if u is a function raised to a power, then we have to tag on another factor here. So we still apply the same rule with the exponents. It's still going to be n times u to the n minus 1. But then we're going to multiply by the derivative of u. Now this is fairly simple. Let me show you just a couple of quick examples here. The first one involves a polynomial raised to a power. So here I have the polynomial x cubed minus 3x squared plus 2 raised to the 7th power. Now in applying this rule, the u is actually the polynomial. So the u is actually just the x cubed minus 3x squared plus 2. And so if you apply this rule, you bring the power down just like you did in the simple power rule. And then so you have 7, and then times the u, which is x cubed minus 3x squared plus 2, raised to the power 1 less than 7. But then here's the catch. You've got to remember to yank the chain on the chain rule. So the last factor here would just be the derivative of what's inside here. So you would multiply by the derivative of what's inside the parentheses, and that would be the derivative of this would be 3x squared minus 6x. So you have to multiply by 3x squared minus 6x. Okay? Now, if you're not in a Calculus 1 class, you can just skip this next example, but here we have tangent to the 5th x. Okay, let me write that a different way for you because some students get confused on powers of trig. So another way to think of tangent to the 5th of x is to think of it as the tangent of x raised to the 5th power. Okay, so let's apply the power rule to this, the general power rule to this. So we would bring the 5 in front of the tangent, and then we would have tangent of x raised to the 4th power. But tangent of x raised to the 4th power can be written as this. Tangent with a 4 here of x. Okay, but then remember you've got to take the derivative of the inside and multiply it by the derivative of the inside. So what you would have here is you would have to multiply by the derivative of this tangent right here. And we learned previously that the derivative of tangent is secant squared x. So again, you have to multiply by the derivative of the inside on that power rule. So that's really what this says. It says you write n times u to the n minus 1, and then you multiply by the derivative of u, where u is the inside. Okay. After we do a few examples, I think you'll catch on pretty quickly here. So here we have a polynomial to the 10th power. So when we take the derivative of a polynomial to the 10th power, we just write it as 10 times the polynomial to the 9th power using the power rule. But then we have to multiply by the derivative of this polynomial here that's on the inside. And that derivative, the derivative of this would be 12x squared minus 14x plus 2. So we have to multiply by that derivative to get the final answer. Okay? Now, another example here would be if we had the square root of a polynomial. First thing you need to do there is rewrite this as the polynomial to the 1/2 power. And then we'll differentiate using the general power rule. So you'll bring the 1/2 down, okay, and then you'll have 1/2 times the function raised to the 1/2 minus 1, and when you do 1/2 minus 1, you'll get negative 1/2 there. But then remember to yank the chain. Multiply by the derivative of what's inside here. So the derivative of x squared minus 5x plus 3 would simply be 2x minus 5. And then the last step, I just rewrote this derivative by putting the term that's raised to a negative power in the denominator and writing the power as a positive number. So in the numerator I have 2x minus 5, and in the denominator I have 2 from here, and then when I move this to the denominator, it gives me x squared minus 5x plus 3 to the 1/2 power. And so there is my derivative of that function. Okay, here's another one where you have to rewrite the function. So here you have 1 over 2x cubed plus 11 to the 4th power. So what we're going to do is we're going to rewrite that as 2x plus 11 raised to the negative 4 power. And then we're going to take the derivative of that using the power rule, the general power rule. So we're going to bring the negative 4 down, and so we'll have negative 4 times 2x cubed plus 11, and then we're going to subtract 1 from negative 4, and it's going to be raised to the negative 5 power. But then remember, you have to multiply by what's inside here, 2x cubed plus 11. So you multiply by the derivative of what's inside here. So the derivative of 2x cubed plus 11 would be 6x squared. So don't forget, it's very important that you don't forget to multiply by the derivative of what's inside when you're applying this general power rule. And then the last step, I went ahead and moved the 2x cubed plus 11 to the negative 5 power to the denominator, and it became 2x cubed plus 11 to the positive 5 power. And then in the numerator, I just went ahead and multiplied negative 4 times 6 and got negative 24, and then of course also have an x squared. So I have negative 24x squared in the numerator over 2x cubed plus 11 to the 5th in the denominator. Okay. All right. Now, again, if you are taking a business calculus class, you can probably skip this example, but I wanted to show you a trig example here. Now remember, when it's written like this, this is like saying the cosine of x quantity cubed. So here I have a function cubed, and that function cubed is cosine of x. So the derivative of a function cubed would be 3 times the function squared. So that's what I have there, 3 times the cosine of x quantity squared. But then remember, you have to multiply by the inside, and the inside is really cosine x. So we multiply by the derivative of cosine x, and we get minus sine x. So that's going to be 3 cosine squared x times minus sine x, and here I just put the minus over here and made it minus 3 times cosine squared x times sine x. Now this example was a power rule example because this is the cosine of a function raised to a power. But there's another form of the chain that you can use with trig functions that has to do with when this x right here is not just x, if it's some function of x like x squared or x cubed. So I'm going to go ahead and end this video here, And then on the next video, I'm going to show you a different application of the chain rule that as it relates to trig rules. So make sure if you need, if you're taking Calculus 1 or you need this information about how to find derivatives of trig functions, you do look at the next video. If you're taking a business calculus class that does not involve trig functions, then you can skip the next video. Okay, now again, feel free to subscribe to my channel on YouTube, and I would be happy to have you following me. Have a good day.